So, my dear students, yesterday we have studied about the conjugate acid base pair and almost all the various concepts regarding the acids and base. So, now after revision, let us move forward and understand the difference between the ionization and dissociation. So, let us study the difference between the ionization and dissociation, my dear students. Yes. Let us first say about the ionization. Formation of positively or negatively charged ions from molecules which are not initially in the ionic state. That means covalent compounds such as HCl, H2CO3, NH4OH, etc. show ionization. That means if the given compound is not an ionic compound, then the ions are not present or ions are not the constituents of that compound. In that case, if the compound is turned into the ions, then this process is known as ionization, and covalent compounds undergo the process of ionization. That means ionization refers to or corresponds to the process in which neutral molecules splits into charged ions in the solution. Now, my dear students, we have the next thing to learn about. It is known as dissociation. So, separation of ions which are already present in an ionic compound. So, if a compound is ionic and when it is added to water, it undergoes the process or it produces the ions. Such process is known as dissociation. Electrovalent or ionic compounds like potassium chloride, lead bromide, etc. So, dissociation. So dissociation refers to the process of separation of ions in water already existing as such in the solid state of the solute. So if in the solid state even the species are available as an ions, especially into the ionic compounds, and they are separated into ions, this process is known as dissociation. So my dear students, please remember that ionization is for the word that is used for the covalent compounds and dissociation is the word that is used for the ionic compounds when they are turned out to be ions when added to the water. So this is how, my dear students, we understand the basic difference between the ionization and dissociation. Now let's understand about the indicators. So here we have a question, write a short note on indicators. So let us study certain water soluble organic compounds like phenolphthalein and bromo bromothymol blue behaves as weak acid. So these are the compounds phenolphthalein or bromothymol blue. They are weak acids and exhibit different colors in their acid form, that is HNIN, and in their conjugate base form, that is IN minus. You can see that if you have HIN and if you remove H plus from it, you will get IN minus. You just minus H plus. So these two are the conjugate acid base pair. This is your acid. This is your base. And thus you have the conjugate acid base pair. And in this you can see that in this conjugate acid base pair, you can see that this and this, they are different in color. So this HIN and IN actually behaves as an indicator and they show the different colors. Such compounds are called indicators. So HIN, which is an acid, when it is added to the water, which behaves as a base here, so it produces H3O plus ion, and you get IN minus, which is conjugate base for this acid. So this indicator has a color A, and this indicator has color B, and that is why it shows the various colors into the two different media, whether it is acidic medium or basic medium, and that is why we call it indicator that indicates whether the medium is acidic or basic, or it indicates the pH sometimes. Such compounds are useful as indicators in acid-base titration and finding out H plus ion concentration. So using these compounds, we can understand the end point. At the same time, we can understand or we can calculate the H plus ion concentration. Some compounds undergo self-ionization and behaves as a both acid as well as base at the same time. So that is what we want to study about, that some compounds undergo self-ionization and behaves as both acid as well as base at the same time. So let us study about them. You can see that water and water, this one water molecule behaves as an acid, another water molecule behaves as a base, and thus we get the conjugate acid H3O plus and conjugate base OH minus. And this is how we understand about the self-ionization of water. Same way when we have NH3 and NH3, these both, one NH3 behaves as an acid, another NH3 behaves as a base, and thus we get conjugate acid NH4 plus and conjugate base NH2 minus. This is also the process in which we understand the self-ionization of ammonia. So this is how, my dear students, we study about the self-ionization of ammonia, the ionization constant of water and its ionic product. So we need to study about now the next topic, that is the ionization constant of water and its ionic product. It's a very important and interesting topic to be studied about. Let us move forward. For pure liquid, my dear students, for pure liquid we can understand in the self-ionization of water, one H2O molecule donates proton and another water molecule donates accept protons. So you can see that during the process of self-ionization of water, this H2O which behaves as a base that accept the H plus, this H2O which behaves as acid donates the protons, this accept the protons, and as it accepts the protons, it turns out to be H3O plus, which is the conjugate base of, which is the conjugate acid of this H2O. This H2O donates H plus and produces the conjugate base, that is OH minus. Now what you can see here, that if there is an equilibrium established between this, we can write an equilibrium constant. So the dissociation constant is represented as K is equal to the concentration of products divided by the concentration of reactants. So we can, for this equilibrium, we can write concentration of H3O plus into the constant, or multiplied by the concentration of OH minus divided by the concentration of H2O. You can even put square here because you have two molecules of H2O. But remember that it is in the liquid state, and that is why the concentration of it is either considered as a constant or it is considered as a unity. So for this H2O square, you can write just K, and that is why we write it this H2O square. For this H2O square, we can write K into H2O square, my dear students. And thus we can easily understand, my dear students, that K into H2O is equal to H3O plus into OH minus. Now for this K into H2O gives a new constant, and that constant we call it as a Kw. So we can write that Kw is equal to K into H2O is equal to H3O plus, concentration of H3O plus and concentration of OH minus. This Kw, a new constant which is produced by the multiplication of K into the concentration of H2O, is known as the ionic product, my dear students. And this ionic product Kw can be expressed as the concentration of H3O plus multiplied by the concentration of OH minus. Now this is what you need to remember, or you need to, yes, that at 298 Kelvin for pure water, the concentration of H2 plus is equal to concentration of OH minus is equal to 1.0 into 10 to the power minus 17 mole per liter. So this is how, my dear students, we can understand that at 25 degrees centigrade temperature, the concentration of H3O plus and concentration of OH minus is same for pure water, and the concentration which is same is 10 to the power minus 7 mole per liter. So we can write that Kw is equal to the concentration of H3O plus or H multiplied by the concentration of OH minus 1 into 1, that is 1, and 10 to the power minus 7 multiplied by 10 to the power minus 7, that is 10 to the power 14. And that is why we can say that Kw has value 10 to the power minus 14 molar square at 298 Kelvin, and that is for pure water. Please remember, this is what we can write it for the pure water. So this is how, my dear students, we understand about the ionic product. The value of Kw is temperature dependent. Remember that the value of Kw or ionic product is temperature dependent. So the value of Kw changes as the temperature changes, and we are well aware that Kw is an equilibrium constant. So please remember that Kw or ionic product is an equilibrium constant and its value changes when the temperature changes. Now let's move forward and understand. Now the density of pure water is 1000 gram per liter and its molar mass is 2 into H plus 1 into O, because we are talking about H2O. So we can calculate the molar mass is equal to 2 into H plus 1 into O. Here H and O represent the atomic mass of the hydrogen and oxygen. So atomic mass of hydrogen is 1 and atomic mass of oxygen is 16, and that is why by putting that we can get 2 ones are 2 and 1 16 plus 16. So 2 plus 16, that is 18 gram per mole. So the molar mass of water is 18 gram per mole. Now we want to find out the molecularity of water. To calculate the molecularity of water, we have the formula: given mass multiplied by 1000 divided by molecular weight multiplied by the volume of solution in ml. So my dear students, if we take the 1 liter of water, in this 1 liter of water we have 1000 gram of water. That is why we have written it clearly that the density of pure water is 1000 gram per liter. That means in 1 liter we have 1000 gram of water. So if you take 1 liter of water, that is 1000 ml of water, we have 1000 gram of water. These 1000 are written as usual, and we have just calculated the molecular weight of water, that is 18 gram per mole. So that is what we put it here, and by doing that we can calculate the molarity of water, and the molarity of water is 55.55 mole per liter. Now ratio of dissociated water divided by the undissociated water. So dissociated water is 10 to the power minus 17, because the concentration of dissociation for H plus and OH minus is 10 to the power minus 17, and the molarity undissociated water is represent the concentration of water. Undissociated water is the concentration of water, and concentration of water is molar represented in molarity. So the undissociated water is 55.55 mole per liter, and by doing or by solving this we can find out that the answer is 1.8 into 10 to the power minus 9, or approximately it is 2 multiplied by 10 to the power minus 9. So this is how we can find out the ratio of dissociated water divided by the undissociated water. Thus, equilibrium lies mainly towards the undissociated water. So, looking at this value, which is of the power 10 to the power minus 9, we can say that the concentration of water which is dissociated is very small, and most of the water remains undissociated in the water. So, thus the equilibrium lies mainly towards the undissociated water, and we can distinguish the so this is how we can say that the self-ionization of water takes place. But remember that mostly or most of the water remains undissociated when it is calculated. We can come to know that for 1 liter of water, hardly 1 point or 2 into 10 to the power minus 9 mole per liter of water is being dissociated. Now we can distinguish the acidic, neutral and basic aqueous solution by relative values of the concentration of H3O plus and OH minus, my dear students. So if we have the concentration of H3O plus is more than the concentration of OH minus, we can say that the solution is acidic in nature. If we have the concentration of H3O plus is equal to the concentration of OH minus, we can say we have a neutral solution. If the concentration of H3O plus is less than the concentration of OH minus, we can say it is basic in nature. And that is how we understand about the acidic, basic and neutral nature of the given solution. So my dear students, if you have any doubt, you can ask me. बच्चों अगर आपको कोई डाउट है तो आप पूछ सकते हैं. अभी जो मैंने पूरी एक्सप्लेनेशन दी, इफ यू हैव एनी डाउट यू कैन आस्क मी. Can you hear me, my dear students?
Yes, sir.
Okay. Do you have any doubt? Is there anything to ask?
Sir.
Okay. Then let's move and understand the new concept, which is known as the pH scale, my dear students. So let us study about the pH scale. So what is pH scale? Let us study hydronium ion concentration or hydrogen ion concentration, whatever you say. Hydronium ion concentration in molarity is more conveniently expressed on a logarithmic scale, and this scale is known as the pH scale. So when you represent the hydronium ion concentration on the logarithmic scale, you actually study about the pH scale. So pH scale is nothing but the logarithmic scale of representation of the hydronium ion concentration. So pH of a solution, if you want to say something about pH of a solution, pH of a solution is defined as the negative logarithm to the base 10 of the activity of hydrogen ions. Once again, pH of a solution is defined as the negative logarithm to the base 10 of the activity AH plus of the hydrogen ion concentration. Now, what is the meaning of the activity of hydrogen ion? That is AH plus is nothing but the concentration of H plus mole per liter. So please remember that activity of hydrogen ion has no unit, but the meaning of activity of hydrogen ion is nothing but the concentration of hydrogen ion per mole per liter. Now in dilute solution, activity of hydrogen ion, that is H plus, is equal to the magnitude of the molarity represented by the H plus ion. So in dilute solution, we can say activity of the hydrogen ion is nothing but the molar concentration of H plus ion in a dilute solution. So we can say that from all the above, we can say that pH, or we can write the formula for pH is equal to minus of pH is equal to minus of log of AH plus minus of log AH plus is equal to minus log of concentration of H plus divided by the mole per liter. So this is how, my dear students, we can easily understand about the pH scale. Once again, I would like to share with you, my dear students, that we can represent, or we can write the pH, uh, we can write the formula for pH, and we can write, my dear students, that pH is equal to minus of activity of H plus ion, or we can write that pH is equal to minus log of concentration of H plus ions. So this is how we understand the uh, pH. Now let's move forward and understand something else. Let's move forward and understand, my dear students. Thus, acidic solution of HCl, which is having the concentration of 10 to the power minus 2 mole per liter, for that we can write the concentration of H plus is equal to 10 to the power minus 2 mole per liter. This 10 to the power minus 2 is nothing but your 0.01 molar. Please remember, your 10 to the power minus 2 is nothing but your 0.01 molar HCl. So if you have the concentration of HCl 0.01 molar, then if you want to find out the pH, you will find pH is equal to minus log of H plus. For that, H plus concentration is 10 to the power minus 2. So now we can write that minus into this, if we have log of A raised to X, then we can write X into log of A. So if we have log of 10 to the power minus 2, then we can write minus 2 log of 10 to the minus 2 log of 10. So this minus is minus. This minus 2 has came into the multiplication, and then we have this log 10. So this simply gives us minus into minus 2 log 10. This minus and minus turns to be plus, and then we have 2 into 1, that is 2. So if we have 0.0, if we have 0.01 molar HCl, then its pH is 2. Same way, if we have 0.001 molar HCl, we can write it as 1 into 10 to the power minus 3, and its pH would be 3, my dear students. Let us understand this. Now, if we have the basic solution of NaOH minus, so that is having the OH minus concentration 10 to the power minus 4 mole per liter. That means the basic ion concentration is 0.0001 mole per liter. That is what it is represented as 10 to the power minus 4, my dear students. Now we are well aware that the concentration of H plus into concentration of OH minus is equal to 10 to the power minus 14, but the value for OH minus concentration is 10 to the power minus 4. So we put H plus concentration into 10 to the power minus 4 is equal to 10 to the power minus 14, and that is why H plus concentration is equal to 10 to the power minus 4 divided by 10 to the power minus 14 divided by 10 to the power minus 4. That is H plus concentration is equal to 10 to the power minus 14 plus 4, and that is what it is equal to 10 to the power minus 10. And thus we can write that the H plus concentration is 10 to the power minus 10, and therefore pH is equal to minus log of H plus, that is minus log of 10 to the power minus 10, that is 10 or minus into minus 10 log of 10, that is what it ultimately leads us to the pH is equal to 10. So remember, my dear students, if we have H plus concentration in the power of 10, then we can write pH very easily. So if we have the 10 plus 10 to the power minus x, then pH is equal to x. So this is how, my dear students, we can easily understand for the calculation of pH for a particular solution. A basic solution of NaH having 10 to the power minus 4 OH minus concentration we'll have pH is equal to 10. So at 298 Kelvin, at 25 degrees centigrade temperature, my dear students, a pure water will have the concentration of H plus, that is 10 to the power minus 7, and OH minus will also have 10 to the power minus 7 mole per liter. And that is why, my dear students, pH is equal to minus log of H plus concentration. H plus concentration is 10 to the power minus 7, and we can get pH is equal to 7. So my dear students, at 298 Kelvin for or 25 degrees centigrade temperature for pure water, the pH of pure water is 7. So please remember that pH of pure water at 298 Kelvin is 7, and thus water is considered to be the neutral species. So my dear students, now we should understand something really very interesting about this, and that is what I'm going to show you. This is what it is known as the pH scale. It is very interesting for you to study this. Now, as we have this is what we call it as a pH scale. We also study about the H plus ion concentration. When we study the pH scale, actually we study about the pH, we study about the H plus ion concentration, we study about the OH minus concentration, and we also study about pOH. So let us study about each of them into the pH scale. I hope you all can see on your screen the pH scale. Dear students, can you see the pH scale on your screen?
Yes, sir.
Everybody?
Yes.
Yes, sir.
Yes, sir.
Yes, I hope it's wonderfully,
Yes,
it
sir.
can be seen on your screen, and that is what now we are going to start studying about. First, we have just studied that if we have pure water, then this pure water will have its pH is equal to 7. So when we have pure water, its pH is equal to 7, my dear students, and that is what it is known as the neutral condition. So if you have your pH, or if the value of pH is 7, it is neutral. Now what we can understand easily, that if the value of pH is less than 7, my dear students, you can see the value of pH is 7. But then what are the other value the pH can have? The pH can have value ranging from 0 to 14. You can see that the pH can have the value ranging from 0 to 14. So it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the value of pH can range from 0 to 14. And if the value of pH is less than 7, that means it may be 6, 5, 4, 3, 2, 1, 0. Then what is the type of solution? You can read it on your screen. What kind of solution is it, my dear students, when the pH is less than 7?
Acidic.
Yes. So if your pH is less than 7, the solution or the given solution is acidic in nature. That is what you can easily understand. If the pH, my dear students, is greater than 7, then you can easily understand that here these are the pH which are greater than 7, 8, 9, 10, 11, 12, 13, 14. And what kind of solution does it represent, my dear students? Let us see it out. Will you please answer what kind of solution it is if the pH is greater than 7?
Basic.
Yes. So when your
Basic.
pH is greater than 7, my dear students, we will have basic solution. So this is how, my dear students, we understand about the basic thing about pH scale. Now, when we study about the pH scale, my dear students, we have just seen that when we have the concentration of, this is what it represents, the concentration of H plus ions. You can see these are all the concentration of H plus ions, my dear students, and these all are all the concentration of OH minus ions. See, I have written the concentration of H plus ion and concentration of OH minus ions to thoroughly to the scale. Now we have just seen that the Kw is equal to the concentration of H plus ion multiplied by the concentration of OH minus ion, my dear students, and this value is always 10 to the power minus 14. So this is what you can see here, that when you have neutral solution, my dear students, the concentration of H plus is 10 to the power minus 7 and concentration of OH minus is 10 to the power minus 7. That means both the concentration of H plus is equal to the concentration of OH minus, and that is what it is. It gives us the neutral condition. So you can see that when we have the neutral solution, the concentration of H plus and OH minus are same. If you go left side, you can see that the concentration of H plus decreases. You can see that, or increases. Actually, the concentration of H plus increases. That means 10 to the power minus 6 is more than the 10 to the power minus 7. So if you go left hand side, the concentration of H plus increases and concentration of OH minus decreases. You can see that for the concentration of H plus, if we see, it turns out to be 10 to the power minus 7, 10 to the power minus 6, 10 to the power minus 5, 10 to the power minus 4, 10 to the power minus 3, 10 to the power minus 2, 10 to the power minus 1, 10 to the power 0. That means here it is 1 molar. 10 to the power 0, that means it is 1 molar. This is 0.1 molar. This is 0.00, sorry, this is 0.01 molar. This is 0.01. This is 0.001. This is for 3. Same with 0.0001. This is 4. 0.00001. This is 5. So as the concentration is decreased by 10, the pH is increased by 1. You can see here. And this is how, if we go from left hand side from the neutral condition, we can see that the concentration of H plus increases and concentration of OH minus decreases, and we get acidic character. Now at any time, if you make the product of concentration of H plus and OH minus, you will always get 10 to the power 14. You can see that 10 to the power minus 6 and 10 to the power minus 8, which is 14. 9 plus 5, 14, 10 plus 4, 14, 11 plus 3, 14, 12 plus 2, 14, 13 plus 1, 14, 14 plus 0, 14. This is how you can understand, my dear students, that the concentration or the product of concentration of H plus and OH minus is always 10 to the power minus 14. You can see here minus 8, minus 6, that is minus 14, minus 9, minus 5, that is minus 14, minus 10, minus 4, that is minus 14, minus 11, minus 3, minus 14, minus 12, minus 2, minus 14, minus 13, minus 1, minus 14, minus 14, 0, that is also minus 14. So this is how we can understand the concentration of H plus and concentration of OH minus. Now we have seen that we can write pH is equal to minus log of H plus concentration. Same way, my dear students, if we write minus log of OH minus concentration, minus log of OH minus concentration, that is what we call it as a pOH. So my dear students, please understand this is what it is, pOH. Now suppose if you take minus log of Kw, if we take minus log of Kw, we will call it, my dear students, pKw. So please remember that if we have minus log of Kw, we call it pKw. If we have minus log of H plus, we will call it pH. If we have minus log of OH minus concentration, we will call it pOH. So my dear students, in this case, you can see that I have even represented pOH here. So these are the values for pOH, you can easily understand. These are the value for pH, that is what you can easily understand. And now let us find out the values of pH and pOH. When pH is 0, my dear students, pOH is 14. That means the sum of pH and pOH is 14. When pH is 1, pOH is 13. 13 plus 1, 14. When pH is 2, pOH is 12. 12 plus 2, 14. When pH is 3, pOH is 11. 11 plus 3, 14. When pH is 4, pOH is 10. 10 plus 4, 14. When pH is 5, pOH is 9. 9 plus 5, 14. When pH is 6, pOH is 8. 6 plus 8, 14. When pH is 7, pOH is also 7. 7 plus 7, 14. When pH is 8, pOH is 6. 6 plus 8, 14. When pH is 9, pOH is 5. 9 plus 5, 14. When pH is 10, pOH is 4. 10 plus 4, 14. When pH is 11, pOH is 3. 11 plus 3, 14. When pH is 12, pOH is 2, 12 plus 2, 14. When pH is 13, pOH is 1, 13 plus 1, 14. When pH is 14, pOH is 0, 14 plus 0, 14. So my dear students, we can easily write that. So my dear students, we can easily write that always this pH plus pOH is equal to 14. Please remember that this pH plus pOH is equal to 14. Now we have just seen that if we write the Kw is nothing but the constant product of concentration of OH plus and H plus, and that is what it is, 10 to the power minus 14, my dear students. But now if we write pKw, my dear students, if we write pKw, then pKw is nothing but your minus log of Kw, and the value of Kw is equal to nothing but minus log of 10 to the power minus 14, and that is what it is equal to, minus into minus 14 and log of 10. Value of log of 10 is equal to 1, and that is what it gives us the value 14. So pKw has always get the value of 14, and we have seen that pH plus pOH is always 14. So for that we can write, my dear students, that pH is equal to pH plus pOH is equal to 14 is equal to pKw. Please remember, because pKw is 14 and pH plus pOH is always 14, and that is why we can say pH plus pOH is equal to pKw. Or my dear students, we can even write it in this way, that suppose you have log of Kw, that is what you can write it, minus log of concentration of OH minus into concentration of H plus. This is what it is, something that we write for Kw. And we know that, my dear students, that log of A plus B, sorry, log of A multiplied by B, that is your log of A plus log of B. And that is why you can write it as a minus log of concentration of H plus and minus log of concentration of OH minus, which is your nothing but, this value is nothing but your pH. So you can write it is equal to pH plus pOH. Thus pH plus pOH is equal to pKw. So this is how, my dear students, please remember that you have pH plus pOH is equal to pKw. So my dear students, here I complete the explanation of pH scale. Now if you have any doubt, you can ask me. Dear students, do you have any doubt into this pH scale? Did you understand well the pH scale, बच्चों?
Yes, sir.
Yes, sir.
अगर कुछ पूछना है तो पूछ सकते हैं, या फिर आगे चलें?
Yes,
Shall we move
sir.
forward? Okay, then whatever we have studied, let us read it from the text, my dear students. That if we have acidic solution possess a concentration of H plus more than 10 to the power minus 7 mole per liter. So if we have the concentration of H plus greater than the 10 to the power minus 7 mole per liter, that means it may be 10 to the power minus 6, 10 to the power minus 5, 10 to the power minus 4. These are the values I am talking about. So when you have the concentration of H plus ion greater than the 10 to the power minus 7 mole per liter, we can say it is an acidic solution. If we have basic solution, then the concentration of H plus ion will be less than the 10 to the power minus 7 mole per liter. That means the concentration may be ranging from 10 to the power minus 7 to 10 to the power minus 14, that is minus 8, minus 9, minus 10, minus 20, and so on. So if the concentration of hydrogen ion is less than 10 to the power minus 7 mole per liter, we can say that the solution is basic in nature. And when the concentration of H plus is equal to 10 to the power minus 7 mole per liter, that means the concentration of OH minus will also be 10 to the power minus 7, and it is a neutral solution because the concentration of both H plus and OH minus are equal. So acidic solution have the pH less than 7. Basic solution will have the pH greater than 7. But if you have a neutral solution, then the pH is equal to 7. Now we are well aware that, my dear students, that at 298 Kelvin for pure water, we can write Kw is equal to the concentration of H3O plus multiplied by concentration of OH minus, which is all having the value of 10 to the power minus 14. Now if we take logarithm both the side, we can write minus log of Kw is equal to minus log of H3O plus in multiplied by OH minus, and that is minus log of 10 to the power 14. Now we are well aware that minus log of 10 to the power 14 is nothing but your 14, my dear students. So we even have discussed that log of A into B is equal to log of A plus log of B, and that is why we can write minus log of H3O plus log of minus log of OH minus. So we can write in one bracket minus log of H3O plus minus log of OH minus. We are well aware that minus log of H3O plus is nothing but your pH, and minus log of OH minus is nothing but your pOH. So we can write these values as a pH and pOH into the next equation, my dear students, and we see that minus log of H3O plus minus log of OH minus is equal to log of 10 to the power minus 14. That is equal to, and minus log of Kw is also written as pKw. Minus log of H3O plus is written as pH, and minus log of OH minus is written as pOH, and minus log of 10 to the power minus 14 is equal to 14. Therefore, we can write pKw is equal to pH plus pOH is equal to 14, or we can even write it in this way, that pKw is equal to pH plus pOH is equal to 14. So this is an important equation, my dear students, which you can learn it well. Now we know that pKw is equal to minus log of Kw, pH is equal to minus log of H plus, or we can even write minus log of H3O plus, and pOH is minus log of OH minus. So this is how, my dear students, we study about the various terms related to the pH scale. Please note that Kw may change with the temperature. We have just seen that Kw is nothing but an equilibrium constant, and this equilibrium or the value of this equilibrium constant may change with the temperature, because equilibrium constant changes with the temperature. The variation in pH with temperature is so small that we often ignore it. So please remember that the variation in pH is ignored by the increase at temperature, because the variation in pH is so small that we simply ignore the variation in pH when the temperature changes. Now pKw is very important quantity for the aqueous solution. Please remember, my dear student, that pKw is a very important quantity for the aqueous solution and controls the relative concentration of hydrogen ion and hydroxyl ions. So that is what it controls, the relative concentration of H plus and OH minus, as their product is a constant. So the concentration of H plus ion and concentration of OH minus ion is always constant, and that is what it is having the value 10 to the power minus 14. Please remember, my dear student, that pH scale is a logarithmic scale. Change in pH by just 1 unit. If you change the pH just by 1 unit, suppose you have pH is equal to 4. That means your H plus ion concentration, is 0.0001. That means it is 1 into 10 to the power minus 4. Please remember. And if you have pH is equal to 5, my dear students, then your H plus ion concentration would be 0.00001. So this you get it by dividing it by dividing it with 10. So if you divide 0.0001 by 10, you get 0.00001. So when the concentration is decreased by 10, please remember that when the concentration is decreased by 10 or by the factor of 10, then the pH is being increased by 1. Once again, when the concentration is decreased by 10, then the pH is increased by 1. That is what I am trying to explain you, my dear students, here. That change in pH by just 1 unit also means the change in concentration by a factor of 10. That is what we can understand about pH. When hydrogen ion concentration changes, that means if H plus ion concentration changes by a factor of 100, then the value of pH changes by 2 units. Please remember that if you have value of pH is equal to 3, let's say, then the hydrogen ion concentration is equal to 0.001. Now if you have pH is equal to 5, then your hydrogen ion concentration is equal to 0.00001, and this value 0.01 is converted to the value of 0.00001. This is possible only when you divide this number with 100. So when you divide this number, sorry, I just made one more mistake. It's a 0.001. If you divide it with 100, my dear student, you get 0.00001. And this you get only when you divide this 0.01 with 100. And that is what the pH, if pH changes from 3 to 5, if the pH changes from 3 to 5, the hydrogen ion concentration is divided by, or the hydrogen ion concentration decreased by the factor of 100. Please remember. So that is what I am trying to tell you here, that my dear students, that if the concentration of H plus changes by a factor of 100, then the pH is changes just by 2 units. So each time when the pH increases, now we realize why the change in pH with the change in temperature is often ignored. So my dear students, for a very small change in H plus ion concentration, pH does not change much. And as for the very small concentration of pH, as the H plus does not change much, we do not often take the change into the H plus ion concentration for the consideration if we have uh, particularly change in temperature that causes a very small concentration change into the H plus ion. So I hope, my dear students, you understand everything very nicely. If you have any doubt, you can ask me. So if you do not have any doubt, my dear students, let us end the class today. Thank you and have a wonderful day.